In this video, I'm going to quickly explain some basic set theory. A set is a collection of distinct unordered objects. So in the first example, there are three objects, 1, 2, and 3. They're distinct because they're different. 1 is not 2, 2 is not 3. Because we don't care how many of each object there are, we just care that at least one exists. And the objects are unordered. So these two sets are actually equivalent, and this set is also equivalent. Another important characteristic of sets is that none of the objects in the set is the set itself. And example 2 is actually not a set, because there's an element within the set that is the set itself. A final characteristic about sets is that the elements of the set don't have to be related. So we could have something like this, 1, 2, and then we could throw in a shape, just a square. And it doesn't really matter. I can put in any picture I want and we can call it an element. And clearly, a squiggly mark in a square and the number 2 aren't necessarily related, but that doesn't matter. They can all be part of the same set. What is the null set? The null set is a set containing no elements, and it's depicted with a circle with a slash through it, or it can be depicted with two brackets that have no elements in it, because the null set contains no elements. And it's important to realize that this set, the set with a zero, just a zero in it, is not equivalent to the null set. Obviously, we think of 0 as nothing. However, in set theory, this is the set that contains 0, and this is the set that doesn't contain anything. So this set will contain one element, but this set contains 0 elements. What is a subset? So a set A is a subset of a set B if every element of set A is in set B. And we can write that as A and then kind of a little c, B. So in the example below, we would say that A is a subset of B because A has two elements, 1 and 2, and both of these are in set B. Though B has an extra element, 3, that doesn't matter because all of set A is in set B. It is also true that every set is a subset of itself. So in the example below, we have A is a set that contains 1 and 2. So it's true that A is a subset of A because all of the elements of A are in A. 1 is in A and 2 is in A. So A is a subset of itself. It's also important to note that the empty set is a subset of every set. So the elements of A is 1, 2 in the empty set. What makes two sets equal? So two sets are equal if they have the same exact objects. So if we go back to the original example, we said that the following three sets are all equal. And that's because we don't care about the ordering of the numbers per the definition of a set, because that every set contains a 1, a 2, and a 3, and nothing else. They're all equal. Thank you for watching. I hope this helped give you a brief introduction to set theory. If you're interested in watching more videos, click the video on the left, which is about a paradox that completely changed the definition of a set. And click the video on the right if you want to learn more about graph theory, which this is a basic introduction for because graph theory requires to have this basic knowledge on set theory. Barring those videos have been uploaded at the time that you're watching this.